Hi, doing a quick little video on Chapter 8.3, Vector Applications. We're finding tension in two strings. Let's recall some basic guidelines or some things to remember about forces. The sum of the forces from the left must be equal to the sum of the forces to the right. We're going to use this. This is going to be important to us. The sum of the forces up must be equal to the sum of the forces down. So forces in the X category will be equal to each other, and forces in the Y category will be equal to each other. Alright? So we'll need that. So hang on, here we go. Here's our diagram. We have a 45-degree angle up here, and a 30-degree angle over here, and then we know that we have these two strings, and it's being pulled down by a 60 Newton force. All right? So we have a vector S that's heading over here and a vector T. Now what I've done is I've drawn these two vectors here in green. In the purple I've got the X category, which will be our cosine, because we do have some force in the X direction. And then we also have some force in the Y direction. So we have force in the X and in the Y direction. All right, so X and Y. Sorry if that's a little light. Okay, so that's going to help us with our sine and cosine. All right, so let's see. What do we do? What's the strategy? Well, just like those forces said, we set them equal to each other. So the left and the right in equation number 1, we'll say that S times the cosine of 45. Right? On the S side, there was 45-degree angle. So the cosine of 45 is equal to T, the cosine of 30 degrees. Secondly, up and down, we have the second equation. We have S as the sine of 45 plus T, the sine of 30. And that must equal 60 newtons because these two are in the Y direction, and that 60 newtons is also in the Y direction. So these two are going up. 60 newtons is pulling it down. All right. So what do we need to do next? Solve equation number 1 for S in terms of T. All right. So here's equation number 1. S will then equal T times the cosine of 30. We're going to move this over. We're going to divide this over here. So divided by the cosine of 45. Well, recall from trig, I use these numbers so we can recall from trig, that the cosine of 30 degrees is root 3 over 2, and the cosine of 45 is root 2 over 2. Well, when we do this, we can cancel these 2's. They're in the denominator. And so we get T times root 3 over root 2. Well, we have to rationalize the denominator, so we multiply square root of 2 by top and bottom. And we will end up getting T times root 6 over 2. So now S is equal to T root 6 over 2. What do we do next? Now we want to substitute what we have here into equation number 2. All right. So here was equation number 2. We basically said that T times root 6 over 2, because that was S, if you recall. That was S from over here. You can't see it anymore. And that was S right there. That's that S. And what we did was we replaced it with T. T root 6 over 2 times the sine of 45 degrees plus the sine of 30 degrees, get my little degrees mark there, is equal to 60 newtons. So T times root 6 over 2, the sine of 45 is root 2 over 2, plus T times the sine of 30. The sine of 30 is 1/2, equals 60 newtons. Now I got root 3 over 2. If you multiply root 6 times root 2, you get root 12 over 4. And then a 2 can come out over 4, so this reduces to root 3 over 2. And then we have plus T times 1/2. We factor out a T. We get root 3 over 2 plus 1/2 is equal to 60 newtons. We get T then will equal 60 divided by the addition of square root of 3 plus 2 plus 1/2. Put that in your calculator, and you get T is equal to 43.92 newtons. All right, awesome. Well, now we can solve for S. Remember, S was T times root 6 over 2. So 43.92 times root 6 over 2. You put that in your calculator, and you get S is equal to 53.79 newtons. All right. Hope you had fun. You might have to pause and rewind that one a couple times. Check it out. But hope you enjoyed that. We'll talk to you soon.